This video lesson aims to help you understand the historical development of atom. Furthermore, you are expected to name the scientists that contributed to the discovery of atom and give their contributions in the development of atomic theory. Atoms are the building blocks of matter that make up everything that we encounter every day. Your ball pen and its ink, the page of your book, and even your body is composed of atoms because you are considered as a matter. Even if we cannot see atom without the aid of the microscope, we can still represent atoms using our cells. From the time the word science was introduced, many people gained interest with the things around them and become fond of asking questions about their surroundings. Up to this time, scientists never stop investigating things. Atomic theory cannot be credited to just one person. It was developed over hundreds of years by several scientists. The history of the study of the atomic nature of matter illustrates the thinking process that goes on in the philosophers' and scientists' heads. Some early Greek philosophers have played pivotal roles concerning the atomic structure. Atomic theory is a scientific theory that states that all matter is made of tiny particles called atoms. Everything, including the air we breathe, is considered to be matter. That means atomic theory impacts just about everyone and everything on the Earth. Some scientists even claim atomic theory is the most important scientific development ever. It is a scientific description of the nature of atoms and matter that combines elements of physics, chemistry, and mathematics. According to modern theory, matter is made of tiny particles called atoms, which are in turn made up of subatomic particles. The theory has evolved over time, from the philosophy of atomism to modern quantum mechanics. Here's a brief history of atomic theory. Democritus, 460 to 370 BCE, a Greek philosopher who began the search for a description of matter. He questioned whether matter could be divided into smaller and smaller pieces forever until eventually the smallest possible piece would be obtained. He believed that the smallest possible piece of matter was indivisible. He named the smallest piece of matter atomos, meaning not to be cut. To Democritus, atoms were small, hard particles that were all made of the same material, but were formed into different shapes and sizes. Philosophers are not scientists. They do not test their ideas. Instead, they use reasoning to back up their beliefs. To them, human reasoning was superior to experimentation. Democritus used an example of a beach to support his theory. From afar, the beach appears to be a solid mass. But up close one finds that a beach is made of small grains of sand too small to be seen from a distance. Democritus proposed that the shape of an atom determined the properties of that substance. Fire atoms had sharp points. This is the reason it hurt you if you put your hand in a fire. Wine atoms were spheres. This is the reason that wine rolled around in a glass. Clay atoms were jagged. This is the reason why clay clumps together when it is molded. Aristotle thought differently than Democritus. He thought that the world was made up of air, water, fire, and earth, instead of tiny particles. Aristotle's ideas were used by the Catholic Church in the Middle Ages, and the people who followed Democritus were shunned or killed. For the next 2,000 years, Aristotle overshadowed Democritus. Finally, in the early 1800s, the atomist theory was revived by John Dalton. In the early 1800s, the English chemist John Dalton performed a number of experiments that eventually led to the acceptance of the idea of atoms. He formulated the first atomic theory since the death of chemistry that occurred during the prior 2,000 years. John Dalton believed in Democritus' work. Because Dalton thought atoms were the smallest particles of matter, he envisioned them as solid, hard spheres, like billiard balls, so he used wooden balls to model them. Dalton theorized that 1. All matter was made of atoms. 2. Atoms were solid spheres. 3. Atoms of different elements differed in masses. 4. Atoms were indivisible and indestructible. 5. Atoms combined to form compounds. In 1886, Goldstein helped contribute to the events that lead to the discovery of the proton. He observed the changes in a cathode ray tube and discovered the anode rays, positively charged particles that moved in the opposite direction, from the anode to the cathode. His work helped Rutherford. He contributed to the events that lead to the discovery of the proton. In 1897, the English scientist named J.J. Thomson provided the first hint that an atom is made of even smaller particles. He discovered the presence of a negative particle in the atom, the electron. He proposed a model of the atom that is sometimes called the plum pudding model. His theory was that atoms are made from a positively charged substance with negatively charged electrons scattered about, like raisins in a pudding or chocolate chips in a cookie. His work proved one of Dalton's ideas wrong. The atom was not indivisible, but in fact made up of multiple components. The discovery was made when he conducted an experiment with a cathode ray tube. When an electrical current was passed through, glowing material could be seen. When he put two electrically charged plated on opposite ends of the tube, the light was bent on the positive plate. Thomson thought that the atom looked like raisin pudding, a ball with negative electrons clumped on it. He dreamed of being an engineer. At 14 he entered college, but his father's early death made it impossible for him to pay the extra engineering fees, so he changed his major to physics. Thomson's model was called the plum pudding model, was named after a popular dessert in England at that time. It was the first model to propose that smaller charged particles make up the atom. Thomson's model lasted less than 2 decades, but it was first to propose the existence of subatomic particles. In 1911, another scientist who worked in Thomson's lab improved on his atomic model. Hontaro Nagaoka, a Japanese physicist, disliked Thomson's model of the atom and created his own. A model that resembled Saturn with its rings. The rings were the electrons and the sphere was the positive center. Hontaro's model was not accurate, and it was left to Bohr and Rutherford to fix that. Ernest Rutherford was born in 1871, the second of 11 children born to a New Zealand farmer. After graduating from college, he traveled to England to work at the Cavendish Laboratory doing research with Hans Geiger on radioactivity. In 1908, he performed an experiment using positively charged particles fired at gold foil. Through his experiment, he proved that atoms are not a pudding filled with a positively charged material. He theorized that atoms have a small, dense, positively charged center, which he called the nucleus. He said that nucleus is tiny compared to the atom as a whole, because the atom is mostly open space. He concluded that the negatively charged particles are scattered outside the nucleus at a distance. In 1909, Rutherford proposed his planetary model of the atom. His model created positively charged protons located in the nucleus and placed electrons in orbit around the nucleus, like planets around the Sun. In 1913, the Danish scientist Niels Bohr proposed an improvement. He built on the concept that the mass of an atom is contained mostly in the nucleus. He also theorized that electrons move in definite orbits around the nucleus, much like planets circle the Sun. These orbits, or energy levels, are located at certain distances from the nucleus. He proposed that electrons are arranged in up to 7 specific energy levels. The arrangement of these electrons in certain energy levels determines the chemical and physical properties of the elements. Erwin Schrödinger built upon the quantum mechanical model. He used a mathematical equation to describe the odds of finding the location of an electron. He called the layers orbitals. These orbitals could be described as electron density clouds. Erwin Schrödinger built upon the quantum mechanical model. He used a mathematical equation to describe the odds of finding the location of an electron. He called the layers orbitals. These orbitals could be described as electron density clouds. In 1932, James Chadwick discovered a third subatomic particle in the atom. He called this particle a neutron because it was neutral. He proposed that neutrons resided in the nucleus of the atom along with protons. As a result of the work done by previous scientists on atomic models, scientists now have a good idea of what an atom looks like. This knowledge is important because it helps us to understand why materials have different properties and why some materials bond with others. It serves as the basic foundation for the study of matter, and it is of major importance to the study of chemistry.